All right, taking a look at worksheet B for chapter 11. I'm going to be going through numbers 1 to 3. So starting out with number 1, we're given a triangle, some given information. So obviously good to give yourself a drawing for something like this. So just give ourselves a drawing of any triangle. Remember, we always label the capital letters for the vertices. So we have E, F, G. And then the lowercase letters are always across from those sides. So this would be lowercase f. And this would be lowercase e. And across from him would be lowercase g. So let's put in the given information here. So angle E is 60 degrees. We got EF is 20. So right here, that's side G. EF is 20. FG we're just keeping as little e, and EG we're just keeping as little f. So there's all our given info for now. The first one, they want us to show that this equation is true using the cosine rule. You know, anytime they say show that and they give you an answer, really important that we really show the work for where that answer came from. So you always want to show as much work as you can anytime it says show that. So anyway, moving this, if we use the cosine rule, we only have one angle to work with. So we're going to be, at the end of this, we're going to need the cosine of 60, which means we are starting with the side across from him. So if we use the cosine rule, which is in our formula packet, we're going to start out with our e squared, and then we got the two other sides, which we know one is 20, the other is f. So we got our 20 squared plus f squared minus 220f. We got our cosine of 60. So that would be our setup for this one. And again, we are showing the work for this, so it's really important that you don't skip any steps and you really show the steps that led up to this stage right here. So even on something like this, like I would not have gone to 40 right off the bat, just because you know, we really want to show the work. Or even the cosine of 60, we're going to be replacing that with 1/2. So anyway, show all the work that we can for this one. So let's do a little cleanup here on the next line. So we got our e squared, we got our 400. Here's where we can start doing some simplifying. So we know that's going to be 40. Cosine of 60 is 1/2. So if we do half of 40, we got our 20. So there's our work right there. Now this one, they want it to look like this. So I got to get everything on the left side and put it in this order. So I'm going to bring, let's see, they want the e squared to be a negative, so I'm going to bring him over to the right. So really now is a very good stage where we can kind of jump straight into this, because all this is moving all the terms onto one side. So now we can say we got our f squared minus our 20f. We got our positive 400, and we're bringing our e squared over. All right, so that's positive, so the parentheses aren't really needed, but since they said to show that it looks like that, we definitely want to format our answer to look like theirs. So there we go. So that was the first part. So now if we say let e equal 28, so now all we have to do is sub in our 28 and then solve. All right, so if we just sub in our 28 for e, then we can solve our quadratic equation here for f. So if we put in a 28 right there, we got 400 minus 28 squared, which is negative 384. So we're solving the equation here of f squared minus 20f minus 384 equals 0. So trying to solve that, of course, we would, probably try factoring, see if that works, see if you could find factors that fit. If you can't find them, you can always go to the quadratic formula to find them. But in this case, it looks like we have ones that fit. We can do the f minus 32 and f plus 12. So we got those two factors. So in this case, we can see that we can say f is 32 or negative 12. But obviously, when you're dealing with side lengths, you could never have a negative length. So that would never make sense. So that's the one that would not work. So when they say explain why one of the solutions must be rejected, real simple. You have to reject the negative length because that wouldn't make sense for a distance in a segment. So moving on to C, so what if E equals 19? So now doing the exact same thing, just plugging in a 19 here instead. So changing the number on that, so if we did 400 minus 19 squared, we get 39. So let me slide this over. So same equation, but now I'm looking at f squared minus 20f plus 39 equals 0. So now we're just solving that equation. And this guy's just pure quadratic formula, so since we don't really have clear factors on this one, so we just start plugging into that one. Remember, quadratic formula is one you do need to know, so make sure you're always familiar with the setup on that. It's not in our formula packet. So we got our b squared, negative b plus or minus square root of b squared minus 4ac, and so a is 1, so I'm not going to put that in. So 4ac all over 2a. So there's our simple setup right there. Clean up the discriminant. Discriminant comes out to be 244. So looking at 20 plus or minus the square root of 244 over 2. And this is a case where they're not asking us for simplest radical form, so we can just get decimals on that. So that'd be the easiest and the quickest way to go. So the two solutions, if we do this correctly in our calculator, are going to be these guys. And since both of those are positive, technically both of those could work, which is why those are both possible cases, is simply because they're both positive. So now they'll want us to try that one more time, letting e equal 10. So show that when e equals 10, there are no solutions. So if we did sub in a 10 for this guy, so 400 minus 100 would give us obviously 300. So if we start plugging into this, a no solution case is going to be a case where you get a negative under the radical. So if our discriminant comes out to be negative, that's why we would have no solutions. So I'm gonna let you do that part on your own. It's really nothing different than what we've already done. If you do plug in your 10 for e here and use that plus 300 as your c value, just plug into the quadratic formula again, you're going to find you got a negative under the radical, which is why that's a no solution case. So moving on to part E. So now we're back to the equation in part A, which was the setup way back up here. There we go. So this is our equation from part A. So determine all values for E for where that value for EG equaling F does not exist as the side of a triangle. So remember on this one, the reason we had a no solution case, like back in part D, was because we had a negative discriminant. So that's what we're looking at. So if we're going to say that the cases that do not exist, that's any case where the discriminant, b squared minus 4ac, is less than 0. So those are going to be our no solution cases. So all we have to look at is the discriminant for this. So going back up to the setup from part A, so if I do my b squared, which would be 400, minus 4ac, 4 times a times c, must be greater than 0 to have solutions. But the way this one was worded, it says show all the cases for where it did not exist. So for this one, it's not going to exist anytime the discriminant is less than 0. So anyway, just some basic solving on this one. Let's maybe just distribute that negative 4 real quick. So you got your 400 minus 1600 plus 4e squared. There we go. Is less than 0. So let's just get e by itself. You got a negative 1200. So I'm going to take my negative 1200, add it over to here, becomes positive 1200, divide it by 4. And I got my e squared. Let's see, 1200 divided by 4 would give us 300. So if I just square root both sides, then I get this. So technically we're supposed to put in that plus or minus, but just think about this logically for a minute. When we say that e has to be less than positive rad 300 and less than negative rad 300, well, if we just say it's got to be less than positive rad 300, that encompasses the negative as well, because that is already less than that. So really we wouldn't need to show both of those. If we simply say that e has to be less than positive rad 300, that already includes the negative rad 300 as well, because this takes up all of that and then some. So that would be enough to encompass all that information in that one statement. All right, moving on here to part E. So find the value of E for which angle G has to be 90 degrees. So let's do a quick redrawing of what that would look like. So if I use my given information from up top, but I'm going to put in G as my, so let's see what we got here. So we got EFG. So EFG. So they're saying G is going to be 90 degrees. Still using the same information that we had up above, the given information. We had side G was 20. We had little e here. Across from that guy, we had a little f right there. So that's what it would look like with the given information and with angle G being 90 degrees. So that would be our drawing. So it's saying what would E have to be in this case? So if the 60 degrees, remember, was E. So if that's 60 and that's 90, that would make this 30. So E is like the long leg of that 30, 60, 90 triangle. So if we use our 30, 60, 90 rules, if the hypotenuse is 20, that would make the short leg 10. And if that's 10, that would make the long leg 10 rad 3. So E would then be 10 rad 3, just based on those 30, 60, 90 rules. So last part here, so if E was 28, and remember that's what we tested back in part B, and we came up with these two solutions right here when E was 28. So find the area of the triangle EFG. So going back up to this, if E was 28, then we figured out that side F was 32. So that was one that we had already figured out. So working with this drawing, area of a triangle, this is a non-right triangle, so I can just do my 1/2 AB sine C formula that we have for this. Let me see if I can squeeze it in right here. So if I did my 1/2 AB sine C. So remember, whenever you're using this formula, A and B have to be the two sides that surround your angle. So they're the two sides that make this guy the included angle. So that's why we're using the 20 and the 32. So anyway, if we replace our sine 60 with rad 3 over 2, so you got your 1/2, you got your 20, your 32, and we're replacing our sine 60 with rad 3 over 2. And so now we could just go ahead and multiply that out. This one didn't say that we had to leave it in simplest radical form, so if it's a case where we do have a calculator, you could just punch that into a calculator to get your answer. If it's a case where you don't have a calculator, or if it specifically says to leave your answer in radical form, then just multiply it out and simplify it as much as you can while keeping your answer in simplest radical form. All right, moving on to number 2. So given a new figure, already been drawn for us. We got some given information, but that's already been put into the diagram for us, which is nice. So we do have a right triangle in here, and then we got some variables thrown in there for a couple of the angles. So find the tangent of this guy in terms of x. So tangent on that guy is just from the right angle. We know tangent from here would be opposite over adjacent, so the tangent of that would just be 2 over x. Find the sum of those angles in terms of x. So I'm finding this entire segment right here. So the tangent on that would be the opposite, which is 12, over the adjacent, which is x. So the tangent from this angle would be opposite over adjacent, which is 12 over x. Moving on to part 3 on that one. Hence means you always have to use your previous answer to then get this. So whenever you see the word hence, you got to use what you just came up with in order to do the next part. If it ever says hence or otherwise, then that then means you could use potentially some other way of doing it. But if it just says hence, you got to use what you just got. So on this one, all right, and this is to show that this is true. So this is another show that question. So remember, for show that questions, really important that you show the work that leads up to this. Anytime you see the show that and they give you the answer, you cannot use this answer to get this answer. So you have to start fresh with what you already have and lead into this. You can't use what they've already given you. So we're just going to plug into this whatever we can. So we already know on the left side that the tangent of those two angles, we already figured out was 12 over x. So I'm going to replace the left side with 12 over x. We don't know what the tangent of theta is. In fact, if you look at the answer, you'll notice tangent of theta is in the answer. So we want to leave that as he is. That's going to become part of our answer. So we're just going to leave that as tan theta for now. We know that tangent of phi, I think that's phi, is 2 over x. So we can plug that in. On bottom, you got 1 minus tan theta times 2 over x. All right, so there's our setup. Really important that we showed that, and now kind of do whatever steps we can that leads us into this. Obviously, I want everything on the right side and just tan theta on the left. So that's our goal for this one, is to be able to isolate that. One thing we could do to start this one out is just cross multiply, since we have a proportion that we're solving. So I can multiply my 12 times this and set it equal to x times this. So in this one, let me just start by multiplying the 12 to this guy. So that brings me to, if I distribute the 12, I got 12 minus 24 over x tan theta. And then on the other side of the equation, I'm multiplying the x times this. So I got my x tan theta. Plus, and then on this case, when I multiply the x times the 2 over x, my x's would cancel, since I'd have one on top and one on bottom. So I would just have my plus 2 right there. So if I just cross multiply, that would be my first step. Obviously, I want to get my tangents onto the same side. So let me, I guess I would add this one over to the right. So let me add that one over to the right. So on the right side here, I got my 24 over x tan theta plus x tan theta. And I think at this point I'm just going to subtract my 2 over to the left. So let me call this 10 instead of 12. So that'd be a good next step. So now that I have my tangents on the same side, I can just factor them out as a greatest common factor. So on that side, if I factor out tan theta, left over I would have my 24 over x plus x. And so now to get tangent theta by itself, I could just divide this over to the other side. So now I got my 10 over 24 over x plus x equals tan theta. And we were kind of shooting for this look here, so I'm almost there. It doesn't quite look like that just yet. So in this case, obviously with a denominator of x, if I just multiply the top and the bottom by x, that should do it for us. So obviously the top would then just become 10x. On bottom, if I distribute this, here they would cancel, so it would just become 24. And right here I would have my x squared. And so now we're getting the look that they were asking for. By doing that, of course, I could just switch those to make it look like this. But notice the work that went into this was we really showed the steps that led into that answer, and that's really important on a show that question, that you show those steps. General rule of thumb, If there is a question, let's just say like this one, that's to show that question, however many points it's worth is typically the minimum number of steps that you need to show. So let's just say this were a 3-point question. We would have to show at least 3 steps of work in order to get the 3 points. But that's like at a minimum. So you always want to show as much as you can though. So moving on to part B. So now use the expressions that we had come up with earlier to find a value for x for which the line OB intersects the angle, bisects the angle AOC. Bisecting meaning it does cut it in half into 2 equal parts, which would mean that that phi is equal to theta is what that's saying. And then it says leave your answer in simplest radical form. Remember the IB word for radical is surd. So, on an IB test, you would see simplest surd form for something like that. So for this one, again, because it's bisecting, that means they're calling the phi equal to theta. They're saying that the 2 angles are equal because that overall angle was bisected or cut in half, which means if the angles are equal, their tangents would be equal. So I know that the tangent of this guy would have to equal the tangent of this guy. And now we can just sub in the information that we already know. We already found out in part I that the tangent of phi was 2 over x. And in part I, we saw that the tangent of theta equals this. So I can replace tan theta with the 10x over the x squared plus 24. So in short, we're just simply saying that the angles are equal because of that word right there. So they want us to clean this up and leave our answer in simplest radical form. So from here, I would just cross multiply again. So I'm going to do the 2 times x squared plus 24. So we got our 2x squared plus 48. And then on the right side, I'm doing x times 10x, which is 10x squared. Let's get everything onto one side. So if I subtract my 2x squared and the 48 over to the right, that would leave me with an 8x squared minus 48 equaling 0. So add over the 48, divide by 8, and you got x squared equals 6. Square root that. Square root both sides. And of course, we're not going to say plus or minus because x is, again, a length and cannot equal a negative number. So always something to consider when you're doing geometry for when you can or cannot use a negative number. So moving on, so use this value of x. Clean this up. So use this value of x to determine the value of the tangent of theta for where it bisects the angle AOC. And it says simplify your answer in that form. So real important that we take the directions very literally. They're also saying that A and B are elements of the natural number system, meaning, remember, natural numbers are 0, 1, 2, 3, 4, and so on. So no negatives, no fractions, no decimals. So anyway, we just figured out that that x would equal rad 6. So we can now, since we're solving for tan theta, go back into this. We know that tan theta equals that expression right there. So I can now replace my x with the rad 6. So on top, I have 10 rad 6. On bottom, I got the rad 6 squared, which is 6, plus 24. So a little cleanup on that. I got my 30 on bottom. And if I just reduce my fraction, it becomes rad 6 over 3. And notice that matches exactly what they were asking for. So in that format, so really important that I leave it like that since that's what they said. Again, so now we have another hence. So again, hence means you have to use the answer you just got. If you know another way of doing this, you can't do it. You got to use what you just came up with because of the word hence. So find the exact value of sine theta. There we go. And then again, leave our answer in that form right there. So really important that we do that. C and D are elements of the natural number system. So we've got to make sure that we have natural numbers in place. So since tan theta equals rad 6 over 3, we got to find a way of using that information to get the sine of theta. Probably the easiest way to do that, I mean, you could maybe use like an identity or something like that, but I think the easiest way would be to just consider a basic triangle. If we had an angle for theta, and tangent does opposite over adjacent, so opposite over adjacent, so tangent would be opposite over adjacent, so sine is going to be opposite over hypotenuse. We just have to figure out what the hypotenuse is. So if we did a little Pythagorean theorem, we could get a value for this. So if we did Pythagorean theorem, let's see, 6 plus 9 is 15, so square root of 15 would go here. So now we could say the sine of theta would be opposite over hypotenuse. So those are both radicals, so we can put them under one big radical. And it's always good to reduce when you can. Since both of those are divisible by 3, we could simplify all the way to that stage right there. The rule of thumb on a IB test, as far as simplifying fractions, is you only have to reduce if your answer comes out to be an integer. Since our answer is not an integer, it's still a fraction, they would accept this as your answer, and so you wouldn't be marked off for that. So, but still always just good to reduce if possible. So moving on to part 4, so use the same value of x and Pythagorean theorem to find some lengths of OB. All right, for these guys, notice with the way they're wording this, so they're referring back to answer BI. So BI was where we figured out that x was rad 6 in that case right there. So that's what they're really referring us back to, is just back to the answer that we came up with for part I, which was the rad 6. So if you kind of go back to the initial triangle here for a minute, let me get this back onto your screen. If I replace x with rad 6, so let's put a rad 6 right there. So if we want to start by finding OB, so just look at that right triangle right there. So OB would be the hypotenuse on that one. So if we did a squared plus b squared equals c squared, then we can get our value for OB. So Pythagorean theorem, so a squared plus b squared equals c squared. We can get our answer for OB that way. So just do a little cleanup. You got 4 plus 6, which is 10, equals OB squared. So square root of 10 would be OB. So that's how we'd get that one. And then the other one they wanted us to come up with was OC. So for OC, now you just look at the entire right triangle. Remember, you got to keep working with the right angle here since you're using Pythagorean theorem. So now we're looking at the triangle as a whole. So this guy would be 12, and then you got still your rad 6, and now we can find the hypotenuse, which is OC. So now if I do my a squared, which would be 12, plus b squared equals c squared. So that would be our other setup to come up with OC using that. So your 12 squared plus rad 6 squared. And for this one, it does say leaving your answer in radical form. It did not say simplest radical form, so we can always take directions very literally. So if we left it in as the square root of 150, that would be acceptable. If we simplify that and put it in simplest radical form, that would be acceptable as well. It did not say simplest surd form, it just said surd form. So if we just leave it in radical form, that would be an acceptable answer. So we always take directions very literally for these. So it just said surd form, so that would be fine. If you did want to simplify that to become 5 rad 6, that would work as well. So either way would be an acceptable answer. So now moving on to the last part here. There we go. So using the results from the last couple that we just came up with, or otherwise. So here's a case where they're saying hence or otherwise. So if we have a different method, we're allowed to use it for this one. So find the area of the triangle OBC. And again, they're drawing us back to the idea that x is rad 6 with that statement right there. And then now this one is giving us kind of a simplest radical form way of writing our answer. So it's going to look like something rad 6 if we do this right, where k is an element of the natural number system. So k has to be something like 0, 1, 2, 3, 4, 5, and so on in order for this to be right. So going back to this one, so let me show you maybe two ways that we could do this. For triangle OBC, OBC is not a right triangle. So we could do the 1/2 AB sine C formula for this. Since we know what this segment and this segment are, and we also know the sine of this was the answer we got back in part B3I. So we could use all that information to do our 1/2 AB sine C formula for it. The reason they're saying or otherwise is because we could also just do the right triangle work. I could do the big right triangle of just a 1/2 base times height to get the big triangle, and then subtract out 1/2 base times height of the little triangle, and that would leave me with this area. So that's another way that you could do it. So that's why they're saying or otherwise, is because there is that method too. But if we did use our previous answers to do this one, then that would be probably the common way, but there is another method. If you just do the big triangle minus the little triangle, that would leave you with triangle OBC. So that works too. So on this one, I'm just going to do the 1/2 AB sine C for this one. So remember the A and the B must be the two sides that surround your angle. So in this case, if we go back up to the answer we got for 3I, we knew that the sine of theta was the rad 2/5. So I can do my 1/2 AB, where A and B are the rad 10 and the rad 150. Because remember, those are the two sides that surround theta. And then the sine of theta, oops, we already figured out was the rad 2/5. So that would be a good setup. So again, we have our 1/2 A, B, sine C. So now we can just do a little cleanup to make it look like this, which is what they're asking for. So if we did multiply all those radicals together, so if you did your 10 times 150 times 2 divided by 5, you're going to get 600 under the radical. So you got your 1/2 on the outside, you got your 600 on the inside. So really important, we can't stop here because they said k has to be a natural number. So cannot be a fraction. A fraction is not a natural number, so we do need some cleanup on this and to go farther. So that's why they're throwing in specifics like this, is to tell you how far you got to go. As well as we need a 6 under the radical. So a little cleanup on that. Think of that as 100 times 6, which would make it 10 rad 6, and half of that would be 5 rad 6. And so now we've kind of filled all the requirements given to us right there. So that would be good enough. So moving on here to the last question in the paper, which is number 3. So let's move on to number 3 here. Let me kind of readjust here. There we go. All right, so last one. So in the diagram, they gave us some given information. So we know that x is greater than 180, which is ABC. So that guy right there, angle B, basically. And then we got some other information that follows. They're telling us that angle C is 60 degrees. So ACB. So we know that guy right there is 60 degrees. So let's just start by filling in our given information here. So we got the ACB, which is 60. And then they're calling angle B X. And then they're calling angle D Y. So we got some given information right there. Starting off the first one, cosine rule to find an expression for AC in terms of cosine X. So again, notice we're using the cosine rule from this angle. which means AC is the side across from that. So using the cosine rule, we're going to say AC squared. And then on the other side, we got the 8 and the 16 would be the other two sides of that triangle. And then again, they said just leave it in terms of cosine x. So that's going to be our setup right there. We can, of course, do some cleanup on that. So if we added those together, you got 320 minus 256 cosine x. And then to get AC by itself, you would square root that. So we're getting an expression for AC in simplest form here. So you got the 320 minus 256 cosine x. And then we square rooted that to get AC by itself. So there's our expression for part A. So use the sine rule in triangle ABC. So same triangle to show that AC also equals this. So we're getting two different expressions for AC. Obviously, if you kind of think of where that's headed, if I have two different expressions that both equal AC, then that must mean those expressions equal each other. And so that gives us a setup that allows us to solve the equation. So same triangle. We're just now using the sine rule instead of the cosine rule. So in this one, we're still talking about angle x. So we could do something like AC over sine x equals 16 over sine 60, using the sine rule for that. So we got our AC over sine x. And then we got the 16 over sine 60. So if I just multiply my, so if I just multiply my sine x over to the right, I can get AC by itself. So now I got my AC equaling 16 sine x over sine 60. And from here, we know that the sine of 60 is rad 3 over 2. So if I did 16 over rad 3 over 2, the over 2, I can multiply up to the top and get the 32. And then on the bottom, I would still have the rad 3. Because on this one, it was a show that question, I guess it would probably be best to show that sine 60 is rad 3 over 2. Because again, for a show that question, you always want to show as much work as possible. So it's really important that you show all the steps that you can that lead up to your answer so that you get all the points. Remember, the general rule of thumb is however many points it's worth, you got to show at least that many steps. So if it's a 4-point question, you got to show at least 4 steps of work that lead up to that answer. So anyway, moving forward, so we now have our expression for AC right here. We got another one right here. So now for part C, it's saying hence, which means use that answer to now solve for x. So because we know that AC equals this and AC equals this, I can set those two things equal to each other in order to solve. All right, so with an equation this complicated, if I set this equal to this, that's a complicated equation to solve. You got two different trig functions, so this is something that would really be intended for calculator use. The best way to solve a complex equation in your calculator is to graph this, and then just find out where those two things intersect, because that's where they would be equal to each other. And so that's what I'm going to do on mine. One thing I'm also noticing is it looks like there's an error up here in the setup. X can't be greater than 180 degrees. That wouldn't make sense for the drawing. So my guess is this was supposed to say X is greater than 90. That's the only way this would make sense. That's probably the same for this guy as well. It wouldn't make sense for that angle to be greater than 180 degrees. So it's got to say greater than 90 for this to make sense. So anyway, so what I did was I'm going to my calculator and I'm going to graph the two equations that AC equaled. So I had AC equaled this, I had AC equaled this, and I'm just going to graph those. I did have to toy with my window a little bit to get them to fit within my screen. And so sometimes that's kind of just a trial and error process. So these were the kind of the window settings that I came up with after just trying a few to find some that fit on my screen. So now when I hit graph, I can get the two graphs. So when you can see there are 2 points of intersection, so there are 2 answers. But when I go under calc and choose intersect, remember it has to be greater than 90. So the first point of intersection is less than 90, so I'm not going to use it. So I'm going to put my cursor near this one. I hit calc, so I just now hit enter, enter, enter to get my value for x. And so this one I got the 94.3 for the x value. So the first part of this, which just had said solve for x, would be that one. So I now got my 94.3 for that point of intersection. AC on this is like the y coordinate, because remember we were once we solve for x and we plug that in, so you now plug that in here for x and you get this answer, which is like the y coordinate of what we just did in the graph, because we basically said y equals this in order to graph it. So you could plug this in by hand and get your answer that way, but if you do recognize that we basically graphed it as y equals this, that also means I could just consider the y coordinate that I just got on my graph as AC, and if I recognize that, I get my answer for AC of 18.4 quicker. But if you didn't recognize that, you could just take your answer of 94.3 and plug it back in, and that would get you your answer as well. So either way works. As far as finding a value for y, so now we're looking for this y value right here. So looking for angle D. So we now know that AC is about 18.4. So now I can come up with y. I can just use the cosine rule again. I don't have any angles up there, so I can't use the sine rule, but I could use the cosine rule. So from that angle, that would make him the side across. So let's see if I can slide this down a little bit. Sorry, I'm just trying to get it all on the screen for you. There we go. So now I could use my cosine rule to find y. So now we can say the 18.4 squared. Then you got your two other sides, which are 10 and 10. We got our cosine of y. So now we can solve that in order to come up with a value for y. So real simple, just you got your 100 plus 100, which is 200. Subtract that over. You could then divide this over into that, and then you just take the inverse cosine of that in order to get your value for y. So if you isolate all that onto the other side, do the inverse cosine, that's what's going to get you your value for y. Looks like it comes out to be 134. So that's how we're coming up with him. Last part, you can now find the area of triangle ADC, which is the top one. And that's where we do the 1/2 A times B cosine C. Or sorry, sine C. So 1/2 AB sine C. Since we know it's 134, you can now do your 1/2 AB sine C. And so we just punch that into our calculator to get the area of that triangle. And that was it for worksheet B.